Hello and welcome back. So far, we've talked about the project that we want to build, or we're going to build, the project description. We talked about the different services. We also talked about the functional and the non-functional requirements. Also, we talked about the decision or the design decisions that will be made. Okay. Now let's see the project architecture. Okay. How the project architecture will look. Now the next slide I'm going to show you is going to show you some diagrams. Now it might look a little bit confusing, but I'll try my best possible to explain. Okay, so the project architecture, we already know the services that we're going to build: the API gateway, the notification service, the auth service, the user service, the chat service, the order service, the review service, the gig service. Okay, so now let's see how the structure will look. Now this is how the project architecture looks. Okay, so I'll start here from the top. Okay, so here we have our clients. Like I already said in the previous video, the client could be your mobile application, it could be your web application, okay, whatever application you are using to access the microservices. Okay, and then it's going to communicate directly with the API gateway. Now the communication between the client and the API gateway is going to be mostly the request response or the synchronous, and then partly the asynchronous when we want to send some events to the clients using Socket.io. Okay, so here you can see the request is going to be HTTP and HTTPS, and also via Socket.io. Okay, and then down here you can see we are going to have an Elasticsearch Kibana instance. Now, what are we going to do with Elasticsearch and Kibana? Now, Elasticsearch provides a very good search feature. So we are going to add our data, our gig data, to Elasticsearch, and then we are going to perform search. If the user wants to search for a particular gig, we are not going to go to MongoDB. We are going to instead use Elasticsearch. So we are going to store our gig data on Elasticsearch. Okay, and then we are also going to store our log data and our application monitoring data on Elasticsearch. Okay, so Elasticsearch and Kibana, they provide the search feature. They also provide the log monitoring. Okay, they also provide application monitoring features and some other features as well. We are going to see how to implement all that. So if you want to implement or monitor your applications, you can do that with Elasticsearch Kibana. All you just need to do is send the required data to Elasticsearch, and then you use Kibana to display. Kibana is just a dashboard. So Elasticsearch is the storage, Kibana is the dashboard. Okay, and then every of our application, because all the data that will be generated, or all the log data that will be generated from our services, we are going to send them to Elasticsearch. I will show you how to set up all of this both locally. We're going to set everything up with Docker and Docker Compose, and we're going to see how to display the data. Okay, so all of our log data, our monitoring data, all will be sent to Elasticsearch. Our gig data, so every gig that a user creates, we are going to store on Elasticsearch and also on MongoDB, but to retrieve the data, we are only going to retrieve from Elasticsearch. And then we are going to use Kibana to view, to display. Okay, so that is why you see these orange arrows from all of these services are pointing to Elasticsearch Kibana, because they're all going to be connected to an instance. We're going to have one instance. Okay, and then another thing we're going to have is RabbitMQ. Here you can see this RabbitMQ icon. Now, this does not mean that each service will have its own instance of RabbitMQ. No, I couldn't create probably another shape to display RabbitMQ. Okay, that was why I just added them individually. We are going to have just one instance of RabbitMQ, and then all of these services will connect to RabbitMQ. Okay, so not one instance per service, but one instance for the whole application. Okay, that is what we are going to have. One instance of RabbitMQ for the whole application, just like we're going to have one instance of Elasticsearch and Kibana for the whole application. Okay, and then each of the microservices will connect to that instance of RabbitMQ. So for the notification service, we are not going to have any database. It will just be get the data then send the email. Okay, so the notification service will just listen for events. So maybe we send an event from the auth service to the notification service. It will listen for the event, and probably if it needs to send an event, it will send an event as well. Now for the auth service, we're also going to connect to RabbitMQ, and it's going to have its own database. Remember I said something about database per service pattern. So this is what the database per service pattern involves. So each service will have its own database. Okay, unlike monolithic architecture where the server has just one database, every feature or subdomain is connected to that database. Here we are using the database per service pattern. So the auth service will have a MySQL database. Yes, just to store data. It's not going to be anything complex. Okay, it's just to store data. The idea is so that you can have you can see how to set up MySQL database. Okay, so the auth service will have MySQL database connected to it, and also to connect to RabbitMQ. Then the user service will connect to MongoDB database. It will connect to RabbitMQ, and then it will connect to Redis. We are also going to have one instance of Redis, but I think we are going to connect the user service and probably the API gateway as well. But the user service will connect to MongoDB, its own MongoDB database, RabbitMQ, and then Redis. Then the gig service. Now this gig service, every gig that will be created by a user, we are going to save an Elasticsearch and MongoDB. Okay, so every gig a user creates will save it on Elasticsearch, and we are going to save on MongoDB. But if we want to retrieve, okay, we are going to only retrieve from Elasticsearch. Now you might decide that you don't need MongoDB, that Elasticsearch is sufficient. It's fine. I just decided to implement it if maybe you want to also get data from MongoDB. But with Elasticsearch, in my own opinion, I think it's sufficient. We don't need to store the data on MongoDB, but I just decided to add it to MongoDB as well. Okay, and then the chat service will save our data on MongoDB, and it will connect it to RabbitMQ. Other service, MongoDB, RabbitMQ, and then the review service, we are going to connect it to PostgreSQL and also to RabbitMQ. So the reviews and the ratings that will be created, we are going to add them to a PostgreSQL. Okay, and then our API gateway will be connected to the Elasticsearch Kibana. Now here, the reason why you are seeing HTTP, HTTPS is because we are going to be using a library, an Elasticsearch library that you behind the scenes uses the connect to the API. Okay, so the client as well, that is our front end. The errors that will be generated on our front end, the monitoring data from our front end, that is our React application, we are going to also send it to Elasticsearch and then view it on Kibana. The same applies to API gateway. With the data and the logs and everything will be sent to Elasticsearch and monitored on Kibana. Now, communication between API gateway and our microservices will be through HTTP, HTTPS. Okay, as you can see. So if you want to send a request, it's going to be through HTTP and HTTPS. And then for this, we are going to use Socket.io. Okay. So this is just the basic idea of how the architecture looks.